While training a machine learning model, what is hyperparameter tuning and why would you choose to use it? Once you move from traditional machine learning models to neural networks, you'll find that the number of design decisions you have to make has really grown and is pretty vast now. All of these design decisions directly affect how performant your model will be, so they are important things to consider. Now, we saw earlier when we were working on simple regression models that there are some basic decisions that you make. In a traditional machine learning model, you'll have to make the choice of the initial values that you assign to the weights and biases that will determine how quickly your model will converge. You'll decide the type of optimizer that you want to use. Do you want to use a simple gradient descent optimizer, or do you want to use a momentum based optimizer such as an Adam optimizer? You'll then decide how many epochs you'll run your training process for. An epoch is basically one complete pass through your training data set. So you'll have to see how many passes you want to make over your training data set. And finally, you might also want to choose a specific batch size. You can't feed in the entire training data in one go, especially if you have huge data sets. You'll feed it in batches. The batch size is also a design decision. If you consider a neural network, there are many more such design decisions that you will have to make. And these design decisions for your training process are the hyperparameters of your neural network. One design decision could be the kind of network topology that you want to use. How are the neurons in the various layers connected to each other? Are they fully connected in that every neuron in one layer is connected to all other neurons in the layer after that, or not? Another design decision is the number of layers you want to include in your neural network. If you have many layers, that is a deep neural network. If you have fewer layers, that is a shallow neural network. This will depend on the complexity of your problem, and you'll find that you'll have to tweak this value to see where you get the best results for your training data set. This is a hyperparameter that you'll have to tweak and choose as well. Another decision is the number of neurons that you want in every layer. Depending on the size of your input, you might decide that the number of neurons in the first layer should be equal to the size of your input. But for every layer after that, you'll need to make an explicit choice or decision. Another significant factor which determines how your neural network performs is the activation function. Should you use the ReLU activation function or the hyperbolic tangent? Is softmax the right decision for you? These are things you'll have to try out and see where you get the best results. If your neural network is prone to the problem of vanishing and exploding gradients, you might use a modified form of the ReLU activation function. We'll see that, the LU activation function, in the next lecture. All of these factors are some examples of the hyperparameters of our model. The hyperparameters are basically parameters which you keep constant during the training process. You make this design decision of what the hyperparameters are going to be before you start training, but these hyperparameters are held constant during the training process, and how well your model performs is sensitive to these hyperparameters. So typically, when you're running a model in production, you perform something called hyperparameter tuning. In the real world, you'll produce a bunch of different machine learning models trained on the same data but different hyperparameters, and you'll basically choose that model which performs the best. In order to make it clear that hyperparameters of a model are different from model parameters, let's understand the differences between the two so that you never get them mixed up. This is a common thing to happen when you first start off with machine learning. The model parameters are basically the weights and biases that are determined during the training process. The hyperparameters refer to the design of the model. These are determined before the training process begins. These are the design decisions that you make for your model. The entire objective of running your model through a training process is to determine the model parameters. The model parameters are the result of the training process, and the model parameters are what you use to make the prediction on real world data. Hyperparameters are an input to the training process. They are the design decisions that you make before you start training. The point of the model parameters is to use it to make predictions. Once the model has been completely trained, it has its weights and biases, and any input that you pass into the model, use those weights and biases to get a classification or some regression value, and so on. The hyperparameters, the point of them is to generate the best possible model, the model with the highest accuracy, the best predictions. Now, how do you decide which model parameters are the best for your model for this training data set? You measure model parameters using validation data sets, and then you'll use metrics such as accuracy to see which model performs best on this validation data sets. For hyperparameters, you use something called hyperparameter tuning to generate that model, which is then evaluated using the validation data sets. So, the best possible model depends on your design decisions. And once you get the best possible model, the way you evaluate that this is the best is by using the validation data set. Hyperparameters are basically part of the design decisions that you make when you set up a neural network to train. Now, your neural network might yield better performance based on different hyperparameters. So, you want to try a bunch of these hyperparameters in combination to see which one yields the best possible model. This tweaking of hyperparameters to get the best possible model is called hyperparameter tuning. So, you use the same training data set, you simply construct your model a little differently by tweaking hyperparameters and then find the best model possible model for your prediction.